Okay, let's talk about the three types of linear equations. So you guys know that when I was going over the syllabus, this is kind of an example I gave you for the lecture quizzes, like what are the three types of linear equations? So in this section, I'm going to go through the definitions. I'm going to talk about how their solution sets vary, and I'm going to give you an example of each. All right, the first one is identity. All right, identity means exactly what you would think it would in English. All right, it's very similar to the word identical, which makes us think of a mirror image. And that's what we see in identity equations, is that if we were to fold the equation over on itself across the equal sign, we get the same thing on top of the other. All right, and so let me grab my pen here and show you what I mean by that. If I were to distribute this 5 inside the parentheses, I'm going to get 5x plus 5. 5x plus 5 equals 5x plus 5. All right, I read the same thing twice. It's identical. All right, this is an identity. If I were to actually try solving for x, I would end up with something that results in 0 equals 0. What this means is that the solution set is satisfied by any number any number we could possibly want to plug in. It's satisfied by 0, it's satisfied by the square root of 2, it is satisfied by the national debt, it is truly satisfied by every number we can think of. All right, moving on, we have conditional linear equations. Conditional equations are what you are used to. It's what we've been dealing with so far, in that we solve the equation and we get an answer. And for linear equations, we get one answer. All right, and so here, let's take the example 5x equals 15. If I try solving this, then obviously I need to get the x by itself. So I'm going to divide both sides by 5. And since the 5's cancel, I end up with x equals 15 divided by 5, or x equals 3. And so our solution set is that one number 3. All right, let me say it one slightly different way. What I'm saying is, if I were to plug in 3, the statement is true. I would get 5 times 3, which is 15, equals 15. Yep, that works. But it is not satisfied by every number. For example, if I plug in 2, then 10 does not equal 15. All right, so again, it's conditional on x being 3. All right, third example, and I just noticed a big old typo up here. Let's go back to that screen, and I will just mark it out for you here in real time. Let's see, grab my pen. This is the fun part of flipping a class. And it should not say conditional up there. It should say inconsistent. And with beautiful handwriting like this is why I don't teach you guys with a board. All right. Whew, that is some pretty handwriting. All right, so let's talk about inconsistent equations. All right, this just means it's inconsistent. It doesn't make sense. All right, an equation that has no solution, all right, is another way to say it. All right, so how do we know that this equation right here has no solution? Well, the math says x equals x plus 1. All right, for those of you that like reading math, then maybe you're saying, okay, well, of course, that's impossible. All right, for those of you that are more English inclined, let me read it to you this way. When does a number equal a number plus 1? When does a number equal itself plus 1? That's impossible, right? 2 does not equal 3. 20 does not equal 21. And if we were to actually solve this for x, well, let's move the x. We subtract x there, we subtract x there, and what do we get here? We get 0 equals 1. Can 0 equal 1? No. Think of it in terms of money. If you have $1, does that mean you're broke? No, it means you have $1. And so clearly this is absurd math, or doesn't make sense. And so our solution set is this funny symbol that actually represents the null set, or it stands for nothing. All right, and we can say the null set or the empty set. All right, so let's go through a couple examples and try to figure out, hey, is this an identity, is this a conditional equation, or is it inconsistent? All right, so we need to solve this. What's going to be our first step? We're going to distribute the 3. Note when I distribute the 3, I get 9x minus 3 equals 9x plus 7. All right, at this point, some of you are going to say, okay, well, it's impossible that 9x minus 3 is going to equal 9x plus 7. All right, if not, no worries. Let's keep solving it further. I'm going to move the minus 3, so that means I add 3 to both sides, which gives me 9x equals 9x plus 10. And at this point, some of you may say, well, that's impossible. It's impossible that 9 times a number equals 9 times that number plus 10. And if you don't see it yet, again, no worries. Let's take it a step further and subtract 9x from each side. All right, and what does that give us? 0 equals 10. Does 0 equal 10? Absolutely not. All right, and again, think of it as money. Having $10, does that mean you're broke? Absolutely not. And so this is ridiculous. This is impossible. 0 cannot equal 10. And so we have a false statement, which means we have an inconsistent equation, and our solution set is the null set or empty set. All right, let's try another one. All right, again, we're just going to start out solving this like we always do. We're going to distribute the minus 2 first. And so I get minus 2x minus 8, and then I just copy my plus 3x equals x minus 8. The first thing I need to do here is simplify the left side. And so since I have minus 2x and plus 3x, that's going to give me plus 1x. And so I have x minus 8 equals x minus 8. All right, again, some of you at this point go, that looks like the same thing on each side. And you could go ahead and choose your answer or solve the problem. Some of you, again, may not see it yet, which is absolutely all right. Let's keep solving. Let's add 8 to both sides. All right, what does that give me? Well, since the 8's cancel on both sides, that's going to give me x equals x. And again, some of you at this point say, well, shoot, that's identical on both sides. X equals x, same thing. And you would go ahead and finish the problem. Again, some of you may say, I'm still not sure, so let's keep solving. I subtract x from each side, and that gives me 0 equals 0. Well, of course 0 equals 0. That is an identity. And since we have an identity, our solution set is all real numbers. We could plug in anything we want and get a true statement. All right, lastly, we could narrow it down by process of elimination and go ahead and figure out what this one would be, but in your homework you won't have that luxury. All right, so let's go ahead and start solving this linear equation. And the first thing I'm going to do is add 4 to both sides. And that gives me 5x equals 15. All right, next thing I'm going to do is try to isolate the x, which means I'm going to divide both sides by 5. And since the 5's cancel on the left, that gives me x equals 3. Does x equal 3? Well, that's a condition. Our statement is going to be true if and only if x equals 3. And so since it's a conditional equation, our solution set is